What I wish I knew about viruses before I learned. Some scientists think they could be aliens. Mind blown, right? Imagine this. Viruses hitching a ride on asteroids, drifting through space for millions of years. If they landed here, could they have shaped life on Earth? Let's dive deep into the cosmic origins theory and explore what it would mean for science, medicine, and our place in the universe. Ready? Let's go. The idea that life came from space isn't new. Ancient civilizations wondered if the gods seeded Earth from the heavens. But it was Swedish scientist Svante Arrhenius who first gave this idea a scientific name. Panspermia, literally meaning seeds everywhere, suggests that life exists throughout the universe, distributed by meteoroids, asteroids, and comets. But here's where it gets interesting. Viruses are unlike any other life form on Earth. They can't reproduce on their own. They're incredibly simple, yet devastatingly effective. Some contain genetic material so ancient, it predates the earliest known life on Earth by millions of years. How is that possible? Unless they didn't originate here at all. Today, scientists like Dr. Chandra Wickramasinghe and the late Sir Fred Hoyle have championed this theory. Their research suggests that viruses could be the ultimate space travelers. For viruses to survive the journey from space, they'd need to endure conditions that would destroy most life forms. Cosmic radiation that would shred DNA. Temperatures near absolute zero that would freeze time itself. And the perfect vacuum of space where nothing should survive. Yet viruses have something most life forms don't. An incredibly tough protein coat that acts like a natural spacecraft. Laboratory tests have shown that some viruses can survive in space-like conditions for decades, even centuries. The European Space Agency has even tested this theory directly. In 2008, they exposed various microorganisms to the harsh environment of space for 18 months. The results were shocking. If viruses came from space, we should find evidence in meteorites. And we do. The Murchison meteorite, which fell in Australia in 1969, contained over 70 different amino acids, the building blocks of life, including some never found on Earth. But that's not all. Meteorites from Mars have been found to contain structures that look remarkably like fossilized bacteria, structures so similar to Earth viruses that they sparked one of the biggest scientific controversies of the 20th century. Headlines around the world proclaimed, "Today we're finding organic molecules throughout the universe. The James Webb Space Telescope has detected complex organic compounds in distant galaxies. Nebulae billions of light years away contain the same chemical signatures we see in Earth's viruses. The universe, it seems, is teeming with the ingredients for life." But not everyone is convinced. Many scientists argue that the evidence is circumstantial at best. They point to contamination issues and argue that life could have easily originated right here on Earth in the primordial soup of our early atmosphere. The famous Miller-Urey experiment proved that amino acids could form naturally from simple chemicals and energy sources available on early Earth. Deep-sea hydrothermal vents provide another compelling origin story. Critics also question the probability. What are the odds that viruses could survive a journey of millions of years through space? The distances are mind-boggling, but panspermia supporters counter with evidence of virus resilience and the sheer number of meteorites that have hit Earth. Billions of space rocks have bombarded our planet over billions of years. Computer models suggest that even if only 1 in a trillion meteorites carried viable viruses, that would still be millions of successful deliveries. The numbers are staggering. If viruses did come from space, it would revolutionize how we understand disease and develop treatments. Instead of fighting Earth-evolved pathogens, we might be battling alien invaders that require completely different approaches to treatment and prevention. New drugs, new therapies. But there's an even bigger question. If space viruses have been arriving for billions of years, have they shaped human evolution? Our DNA contains viral sequences, some so ancient they might be fossils of cosmic visitors that helped create us. We might literally be part alien. This theory also changes how we approach space exploration. If we're looking for life on Mars or Europa, we need to be incredibly careful about contamination. We could accidentally introduce Earth viruses to other worlds, or worse, bring alien pathogens back to Earth. The stakes couldn't be higher. Whether or not viruses came from space, This theory forces us to think bigger about life in the universe. We're not isolated on this pale blue dot. We're part of a cosmic web of matter and energy that connects every star, every planet, every living thing. And if viruses can travel between worlds, then life is far more resilient and widespread than we ever imagined. From the smallest virus, to the largest whale, to the vast networks of forest fungi. If life can spread naturally through space, then perhaps we're meant to be explorers, carrying Earth's biological heritage to new worlds. We might be the universe's gardeners. The search for answers continues. Every new discovery brings us closer to understanding our cosmic origins. Scientists around the world are working to solve this puzzle, and maybe, just maybe, the next time you catch a cold, you'll remember that you might be experiencing a message from the stars. In a universe of infinite possibilities, the idea that we're connected to the cosmos through the smallest forms of life is perhaps the most beautiful theory of all.